Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that determining the total current I in the given circuit. So when you analyze this circuit, to solve it we have to first find the equivalent resistance. We already have the voltage, we need resistance to find the current. Now if this current enters here like this, it will be very difficult to find the equivalent resistance. So when the current enters here, it will split into two branches. Some will enter 20 ohms, some will enter 10 ohms. When it comes here, it will also split here again and also split here. And when it comes here, it will also split here and split here. So there are different directions that the current is going. So you cannot determine truly the resistances that are in series and in parallel. Like if it comes here now, it will come here and enter here again. So it's difficult for you to solve this circuit like this. You need to convert this network into a star network, because if you look closely, this is one resistance, this is another resistance, this is the third resistance. It's only connected here. It went here and came down. But if you adjust this one in, it will be like this. So it will be a triangle, it will be a delta network. So this will be a delta network. LMN is a delta network. It has three resistances. And you only need to remove this branch here and join it, fix it here, so that it will become a perfect delta network. The reason we are converting this delta to star is because this network is complex. It's difficult for you to know the resistances that are in series and in parallel. Unlike the usual easy ones that we do, this one is a complex circuit. You cannot really know from the network, from the current entering it. You will not really know the direction. You will not really know the ones that are in series and the ones that are in parallel. But if you can convert it to a star network now, it will be like this. We will easily know the one that is in series and the one that is parallel. Star networks are easier to analyze than delta networks. So that will help us to easily find the equivalent resistance. So now let's do this. So this point, this one, we are going to convert these two. So this is the delta network. Here is L, here is M, and here is N. So here will be what? 10 ohms. Then here will be 25 ohms. And here will be what? 15 ohms. I will need to convert it to a star network. So I'll call this one, let me say this one is R1, then R2, then R3. So you can call this one R3, you can call this one R2, you can call it anything you want. But where L is attached, you will get the answer. Do not put the answer of the L branch on the M branch, and do not put that of the M branch on the N branch. That's just the main thing. Or you can call this anything, even RX, RY, RZ, you can call it anything. You will still get the same answer that is supposed to be there on this branch. So now to find R1, you know it will be you need to find R1, you know it will be 25 times 10 divided by the sum. So solution. So R1 is what? 25 times 10. If you like, you can call this one R12, you can call this one R23, you can call this one R31. Then you can do the formula first before you substitute it. It's the same thing. So this one, I'll go straight to the point. To be R1 equals what? 25 times 10. 25 times 10 over the sum. That is 25 plus 15 plus 10. 5 plus 15 plus 10. So over the sum, these two, that's the sum. 25 plus 15 plus 10. So this is what? 25 times 10 over 25 plus 15 plus 10. This is 5 ohms. So here is 5 ohms, 5 ohms. Then R2, on do it here. R2 is what? Is 15 times 10 over what? 15 plus 10 plus 25. 15 times 10 plus 15 plus 10 plus 25 is 3 ohms. No, 3 ohms. So this R2 is what? Is 3 ohms. Then R3 now. R3 is what? Is 15 times 25 for the sum. 15 times 25. 25 plus 15 plus 15 plus 10. That's 7.5. So it's 7.5 ohms. So we have successfully converted the delta network to star network. Now we can go straight to find the equivalent resistance. But first, we have to redraw this circuit. So it will be what? Let me redraw it here. Okay, there will be 20 and 10 here. This is 20 and 10. Then this one is now like this. So this L will be here, and this M will be here, and this N will be here. So I'll just join L to this one and M to this one, as it were before. So here is L, and here is M. Going to be like this. Then here this point. Then N. Here is connected to N, but there's a resistance which is this one connected to N. Here will be N. No, this is L, M, and N. Because initially L and M was connected. L was to 20 here, 20 ohm, and M was to where? 10. So now this L is what? Here is 5, and here is 7.5. Then here is what? Is 3. Is 3. Is 3. Then the other one. Here I think here then okay, it's P. Here is P. Here is P. So we'll put P here. Then we'll draw the circuit. Here there's a voltage source. The current is coming here, I. Then here is 2.5 ohms. 2.5 ohms. 2.5 ohms. And then here is downward. So that's all. Here is 2.5 ohms. Here is 15 volt. So now this is our circuit now. So now, this is the positive terminal. The current will flow from here, from the positive terminal of the voltage, and will come back to the negative terminal of the voltage. So this is the positive one, this is the negative one. So there's a current flowing from here like this. When the current comes to P, it will split in two. Part will enter here, part will enter here, and they'll still come and meet here and flow until they come back to the negative terminal. So this is the positive terminal, this is the negative terminal. Or the longer one is always the positive one, and the shorter one is the negative one. So since this current, so now that means since the same amount of current enters 20 ohm and 5 ohm resistor, these two are in series. Likewise, 10 ohm and 7.5, these two are also in series. And since the current, when it enters the point P, it splits. A portion of it enters this branch and a portion of it enters this branch. That means this branch, the resistance in this branch and the resistance in this branch, they are parallel to each other. So the two sums will be parallel to each other. And when the current comes to this point, they both current joins and the same amount will pass through 3 ohm and 2.5 ohm, and they will enter here. So that means 3 ohm and 2.5 ohm are in series since the same amount of current enters there. So that means we know that 20 ohm plus 5 ohm, since these two are in series, will be parallel to 10 ohm plus 7.5 ohm, since these two are also in series. Therefore, this is what 25 ohm is parallel to what? Is parallel to what? 17.5 ohm. Now, since these are two resistors now, so this means that here will become one resistor, here will become one resistor. So these two resistors will be parallel to each other. And the equivalent resistance is what? Is product over sum. So it will be product times 17.5 over the sum, which is 25 plus 17.5. So 25 times 17.5 over 25 plus 17.5. So this becomes what? 10.2941. All I used to approximate, but since I'm still going to use this resistance in another calculation, I'm not going to approximate. So I'll just approximate it to maybe 2 decimal or 4 decimal place, anyone. So this, let me approximate it to 2 decimal place, 10.29. If you approximate L, maybe if I take 10 ohms, you won't arrive at the final answer. So at this early stages, it is important you do not prematurely approximate your values since you are going to use it in more calculations. If not, you won't arrive at the correct answer. So let me write 10.29 ohms. So now this is 10.29 ohms. This 10.29 ohms, if you redraw the circuit becomes like this. So now this becomes 10.29 ohms. This becomes what? 3 ohms. And here is 2.5 ohms. Now here becomes P. Your P is now here. And your N is now here. So all this has been converted to this one. So to get 10, so all this gave us 10.29 ohms. Now there's a current that will flow from here in this circuit and it will enter here. So all this, the same amount of current will enter all these resistors and will come back to the negative terminal. Because current, you know that current flows from the positive terminal and comes back to the negative terminal. So now we can add all these resistors because all of them are in series. So the equivalent resistance of all this is the summation of all the resistance of all the resistors. So now the equivalent resistance becomes what? 10.29 plus 3 plus 2.5. No, 10.29 plus 3 plus 2.5 is 15.79. So this becomes 15.79 ohms. According to Ohm's law, the formula for Ohm's law is voltage equals to the product of current times resistance. Now we need to find the current in this circuit. So current now becomes voltage divided by resistance. So the voltage is 15 volts over the resistance, which is 15.79. So according to Ohm's law, voltage equals current times resistance. So current now equals voltage over resistance. And the voltage in this circuit is 15 volts divided by 15.79 ohms, which is the resistance, the equivalent resistance of this whole circuit. So it will be only one voltage connected in series with only one resistance. So it will be like something like this. There's current, so the voltage is 15 volts. Here is the current, and the resistance is 15.79 ohms. So this is the final circuit, and the current is given by this Ohm's law, 15 divided by 15.79. So 15 divided by, so 15 divided by 15.79. So this is 0.9499, which is approximately 0.95. So current now equals 0.95 ampere. This is the final answer. So the current in this circuit, the total current in this circuit is 0.95 ampere. That's the final answer. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.